Okay, so these are going to be our talks this evening. And with this, I hand over to our very first speaker, Rita, to introduce herself. And
as a background on myself, I've been many years as a software engineer in different companies. At the beginning, I guess I started my career more focusing machine learning and data problems, business intelligence, analytics, end up being and building myself as a full stack engineer. So, well, did a lot of backend in Java, C++, C Sharps, but then eventually end up doing as well web development and either, I don't know, React, JavaScript, everything. So I end up doing a little bit of that. End up knowing MongoDB in one of my previous companies, Workday actually. We start using MongoDB for our only internal tools. And then I got just really fallen in love by the product, I have to say, as a developer. Joined MongoDB the first time as a pre-sales solution architect, and then eventually made my way for developer relationships. And today I'm here to talk about how MongoDB data modeling really takes the code first approach. And before I go into comparing the code first approach with the model first approach, I wanted to talk about as well that there is also the database first approach. And the idea behind this is, and sometimes actually people did say that code first approach is actually the application first approach. So the idea here is when you're thinking about modeling your data, you should be first thinking what are the requirements for your application, for your microservice first, or are they going to, how is going to be used by the users? And that's kind of the code first approach. Think first on how you're going to model your code, how you're going to define your classes and objects, and then eventually you will define the model and you will, of course, define the database. The model first approach goes a little bit different. It does say, think about your kind of entity first, define your model, and then create the application and with it, the database. And there is also the database first approach that says, you already have part of your database created, you're just making an evolution on your database, and you want to apply that back into the application. But MongoDB really, for you to be successful with data modeling, you should think on your application. So we really take the code first approach. But let's compare it. And I'll start saying, I'm not trying to do here a competition between non-SQL and SQL, but as well as part of my own experience, a lot of years modeling for relational databases, it would be very typical and very normal to start with the model first approach. So the step one always, as I remember, would be, I would definitely define a schema. Eventually, after defining the schema, I would start thinking about the application and the queries for the applications. So we typically would build our entity relationship model, start defining the relationships of the data, including the data types, and then I would go back to my application and start building the application on top. That's a very common way of thinking on when starting an application, especially in my particular in my particular experience where I came from the database world first. So a lot of problems were solved at the database level even, and then they would come eventually to the application. But that sometimes does kind of start raising a little bit of concerns. So do you want to, when you're doing the work, thinking on your model first, on your tables and relationships, you want to make sure, is this correct for how the users are going to use the data within the application or my service? Or eventually, you don't know if you need to potentially denormalize it. So you started having all of these kind of concerns of, okay, is the way I model my data actually the way the data is going to be used by the users that are being used by my application? So the reality is who really dictates how the data is used is the users that are going to use the application, or the different applications that use your service that you're building for. So I skip this one here. So the reality is you really, if you want to continue even doing the evolution of your application and service, you really need to start thinking a little bit more on, oh, sorry, here we go, this way, on how can you transform your model all the time and then apply it back to the application. So in the modeling for MongoDB, we start with the code first approach. And the idea is, there's something funky with my slides, I apologize. The idea is we did start with developing the application, and developing the application is understanding the business requirements, is understanding who's my audience for the application, how they're going to use, and how then from there are going to be the queries and workloads for my application. So only then, when you define how it's going to use your objects and classes, you're going to start defining the data model. And it's important because when you are even defining your objects and classes and design patterns of your classes, you're going to start thinking how the operations of the data, how the data that I'm going to query is going to be together or not together, or the types of data, et cetera, et cetera. So then the code first approach is really think about how you're going to build your application first, then define the data model for it. And that will, when it comes to improve the application, is going to be a cycle improving the data model. And it becomes natural. It becomes, okay, I'm changing, I'm adding a new class, I'm adding a new operation on my class. I'm going to make sure that my data model is going to evolve with that. And it becomes kind of a symbiotic cycle between them. And the reality, this is how we should be doing data modeling for MongoDB, because it's kind of a rule of thumb for us is the data should be stored together, the data is stored together, how it's accessed. So if, for example, I'm going to a doctor and I want the doctor is going to, pull in my document about my information and where do I live and if I had exams in the past. So depending how that action of, his need actually is to get my full profile all the time, right? It's going to say, I need to know Rita, I need to know her background and history of data. So it makes sense that every time there is a database storing documents for patients, it makes sense for the data to be together. So if the cycle of improving your application and improving your data model is actually a symbiosis, a cycle together, a smooth, you will have many design options, and you can design for users of pattern, and your data model evolution becomes easy. So any evolution you do in your object model becomes easy to transform it and bring it back to the data model. And some of the design patterns you apply on your objects become also design patterns for your database. So the other thing that is really important is you can evolve without any downtime, meaning that if I'm adding a new operation, if I'm adding a new class in my application, when the application goes, I don't the change of the application and the database, they are basically coupled together. They're not necessarily, I need to change first the database, make sure it is compatible with the application, and that becomes a natural way of deploying your new evolution of your code. So for that, if you think about application first, if you think about how I'm handling the data at the object level and my application becomes how I handle the data in MongoDB, there is a couple of a certain methodology that we we like to follow to achieve what we call near magic formula. So it's kind of a step-by-step iteration. Again, as I said, you really need to study your business domain expertise. You need to know how your users are going to use your application or service. You need to define and predicate the current scenarios. And you need to make sure that you understand if it is a current application, if it is a current service that you make in evolution, you learn with your production logs and stats. With that, you are evaluating the full application workload. You will understand the data size, and most importantly, you will understand those list of operations that are ranked by importance. So when we said study first how the data is going to be accessed, because we really want to make sure that the top operations are being used are going to be optimized for how you read and write your data. This is very important. And this is the first step of the iteration of our magic formula. And with that, you'll get your data size, you'll get your database queries and indexes, and you'll define your current operations and assumptions. Then afterward, and not before, so again, code first, application first, understand the workloads first, then just after that, you're going to start defining and mapping your entities and their relationships. So going to look at your application, understand how the objects are defined, the data that flow through them, how they're going to be used, and then you start thinking about your collection relationship diagram. And for you that don't know, well, I guess most of you know MongoDB, but we don't use tables, we do use collections. So we typically say collection relationship diagram. And we do have relationships, and it does make sense to create those relationships. So that comes to the next point, which is link versus embedded. So what is the right decision, and what does this mean? So let's give an example here of all the different types of relationships that we know. And typically this would be, for example, a user creating articles. So one user can create several articles. A user can have several comments for those articles. Those articles can have many tags. Those tags, for example, if we're talking about creating technical content like Java content, Java is a tag that could be related to many articles. And articles can be categorized, for example, in language or products or technologies. And let's imagine this is kind of your different objects and entities that you want to map. Now, we could have said this is a way of doing it. And if it was the model first approach, this is how I would design my database. And this is how my application would end up being created. But would I select the linked approach or the relation approach? Such as, for example, in this case, there is an author that has a one-to-one relationship with a book. I have the book connected to the author you can see there. A book has an ID 1 that is connected with the author 1 that has another document. So those are two different documents in two different collections, and they have a linked relationship that you can see there using the author and book 1. How would this look on an embedded relationship? So if it would make sense that your application, your users, every time they were searching for a book, they would also want to know about the author information, you would embed the author information within the document book, within the book collection. If that was not the case, and every time, most of the times you were just searching for books and you didn't want to know specifically the author, you could potentially leave them in separate collections and link them. Let's talk about the one-to-many. So here we have the authors that have a relationship with books as well, but they have many books. So this author has 3 books, and this is a way of representing the relationship with them using arrays. Now, let's say that instead of, and this is a kind of embedded approach, let's say that this is a more separate approach. So we'll have a scalaring child approach. So book 1 has author 1, book 2 has author 1 as well. Now, let's see the case of many-to-many. So if you see here, the book will have a relationship to many authors, and an author would have a relationship with many books. So the reality is, would you embed all? Would it be easier versus the embed and linked approach? Again, it really depends how the data is being accessed on your application, how your application was built. Was it built for every time someone is logging in the application to know about the articles for a blog post, to get all the blog posts with all the tags, with all the categories, with all the comments? Or was it built in a way that you would do it per user, you'll get all the articles for that user? So it depends. To be fair, there will be, I would see in reality, different use cases to have the queries all by articles or having the queries by users and articles. So we need to think sometimes when we are after understanding the workloads and our queries and we know the top operations that we're going to do, we need to always make this decision between will we link or embed. And it's not one formula for all. Different types of different types of object, different types of access of data will mean different things. So you need to make these questions. How often does the information, the embedded information gets access? So if the embedded information, for example, if we go back to the author and the book, actually the book that has an author, if most of the times when I'm trying to get a book information, I always want to know the author, then it makes sense to be embedded. Is the data queried using the embedded information? So exactly the same thing is if I'm actually searching for books, but I'm not using the author information, it doesn't make sense for it to be embedded. Does the embedded information change often? So this beyond just reading data and getting data, that is it always changing? And does it make sense to be separately from my read and write operations? So if we go back to our step-by-step iteration, we've done that. We studied our workloads. We understand where we are doing our cycle of evolution of an application or our microservice, and we're understanding how the data size, what my operations are, ranked by the importance. We mapped our entities. We define what's going to be linked, what's going to be embedded based on our application. Now we need to really finalize the data model for each collection. And for that, we really need to identify and apply relevant design patterns. We're going to define the collection with the document fields and shapes for each, the data size, the database queries and indexes, and we'll finally end up with the current operations and growth projections for the future. You will understand much more the evolution of your data and data model usage. For that today, I was not going to talk about design patterns. I was just focusing on the modeling of the approach of modeling your data using the application first. I wanted to share that if you want to learn a little bit more, you can go to our MongoDB Developer Hub. We have a couple of articles detailing more the schema design patterns. We have the data model example and patterns in the MongoDB documentation. You have the MongoDB forums that also have this type of discussions about data modeling. And if you like books like me, you can also go to O'Reilly. The first one, which is more focused on .NET and is actually focusing on even modeling your data with relation databases for focusing on the code first is programming entity framework. And the second one will be design patterns, elements of reusable object-oriented software that will, allow you to think on your code first, on your design patterns of your objects and classes that you could potentially, after defining that, reflect that in your data model and design patterns on MongoDB database.
Hello, everybody. Thank you, Rita. That was really interesting, and it slightly overlaps with what I'm going to talk about. Can everybody hear me?
Yeah.
Yep. Yeah. Thank you. So first of all, I'd like to thank Henna for organizing the event and for giving me this opportunity to speak. And yeah, thank you for coming. It's great to see everybody in person. We've been isolated for so long. So my name is Sheila Doyle, and I'm going to talk to you today about query optimization in MongoDB. A little bit about me. I work as a technical services engineer on the technical services team, on the core team, and I have a special focus on queries and indexing, because this is one of the most rewarding areas in my opinion. We typically on our team deal with questions and issues from our many customers, which vary from system down to how can I make my query go faster? Can you help me write this aggregation operation? So the focus is to help our customers to be successful with MongoDB. A lot of the issues that we deal with stem from unoptimized workload. And that's why when Henna asked me to talk about anything, my idea was to talk to you about how to optimize your workload. First of all, I'd like to ask, does anybody here use MongoDB? Do you have a cluster? Great. And how many people have tried to tune a query? Okay, so we have some experts here. And in fact, some of what Rita has said is very applicable to what I'll be telling you. So the objective for me today is to impart some hints and tips on how to overcome many of the pitfalls that we see when our customers get into trouble and contact us. So what I'm going to look at is the importance of indexing. It's so important to index your queries. And we'll look at how you can cover a query so that it doesn't actually need to scan any documents. And we'll look at some pitfalls, the famous pitfalls of blocking sort operations and the use of regular expressions. There are some hints and tips on some optimizations that we can recommend to optimize your write operations. And Rita has already covered this part, but it's really important to have a very good foundation and a good schema design. Many, many years ago, I was tasked with working on a project, and my task was to do the data model. It was for a bank in Turkey. Very interesting project. So I got out my data design notes, and I decided to take the data model to the fourth normal form. Is there a fourth normal form? And we ended up with something like 160 tables. It was a relational model. So once we came up with the design and then we started looking at the reporting, we realized that this wasn't going to work. So that was a really good use case for a code first approach. And I think I'll emphasize again that in MongoDB, it likes a flat data model. When you're querying large amounts of data, it makes more sense to have a flat data model rather than to be linking to other tables or collections. And then I'm just going to quickly cover at the end a new feature. In MongoDB, we are forever developing new features and improving the product all the time. And one of the new features, which is quite recent, which is particularly interesting in the interest of performance, is our time series collections. So we'll talk a little bit about those. There'll be some time for questions at the end. So first, let's talk about indexing. So first of all, what is an index? So an index is basically just like an index is in the back of a book. So why would you page through a book to find a document that you're interested in when you can go directly to the back and be taken straight to the page if you access the index? So in MongoDB, we use indexes to improve query target ratios. So typically when a query runs, it will access a number of documents, but we might only want to return a small number of those documents. And without indexes, our queries sometimes end up doing full collection scans. And we have big data, so this could be millions of documents. So you can imagine the amount of resources that such a query would take. So we use indexes to improve query target ratios. I'm going to talk to you about, we have a rule of thumb for identifying the order of the keys, and in fact, the keys that you should place in your index when you're creating them. And it's also important to order when it comes to using the aggregation operation, to order the pipeline in such a way that it will use the index. So query target ratios, we have two: document scanned to documents returned, and index key scan to documents returned. For anyone who uses Atlas, you may have noticed that you'll automatically get an alert if your query target ratio reaches beyond, I think it's 1000 by default. So in Atlas, we do certain things to help you manage your cluster or the database on your cluster in the interest of performance. So from a performance viewpoint, we want to keep these query target ratios down. An ideal query target ratio would be that we access one document to return one document, or if we want to return 10 documents, we just access 10 documents. Many of the workloads that we see in technical support are accessing thousands of documents to return just one. So can you imagine the impact that that has on cluster resources? In these cases, cluster resources, CPU, disk, memory are being wasted. And so we're interested in helping you to optimize your workload so that you don't have to pay for all those resources. And perhaps your workload can exist on a lower tiered cluster. When you're running your queries and you've created your indexes, we have a method called explain that will run an explain plan, which I recommend you use to examine how your query is operating. And I have an extract of an explain plan that I will show you, which demonstrates how it shows you what your query target ratio is. But Atlas also has features that show you an explain plan, the Atlas profiler. So we've established the reason we use indexes is to bring our query target ratio down. So when it comes to creating the index, what keys should we put in the index? So we have a rule of thumb, our ESR rule, E for equality, sort, and range. So basically, the fields in your query that you're matching on for using an equality match should come first in the index. After that, the sort keys, and then finally the range keys. And the reason for this order is so that we can have the correct index bounds for an efficient query. So it's quite simple. I won't go into detail, but if your collections were sharded, then you might have the shard key at the end. But I think that's for another talk. Here we have an example. I don't know if you can see the text, but I have an example of a query and an index that you might create to support that query. We have a collection called cars. We're using an equality match on the manufacturer field and a range match on the cost field, and we're sorting by model. So we can see the index to support this is has 3 keys: manufacturer, model, and cost. I remember when I joined MongoDB at first, it took me a while to get my head around this, but now I see it every day and it's really simple. Not all aggregation stages use indexes, and we recommend that those that do should be placed early in the pipeline if your use case allows. So the stages that do use an index are match, sort, and geonear, which uses geospatial indexes. So, but I think most queries are doing some kind of a match. We see queries that are doing a count on all the documents in a collection. And we can kind of fool those queries into using an index by prefixing the count stage with a match or a sort stage. But typically these stages should appear earlier in your pipeline. We can cover queries by ensuring that all the fields that are returned in a query exist in an index. So a query that is covered is not just one that's supported by an index, but it's a query that takes all the fields that are returned in the documents from the index. So covered queries don't actually access any documents at all. You can think of an index as being a subset of a document, which is readily available in the cache. So to make a query a covered query, then all the projected fields should exist in the index together with the sort and order fields. So covered queries, can anybody think of why it might not be such a good idea to cover all queries? You might ask that question. So remember, indexes do come at a cost. Every time you update a field that is indexed, then all the indexes that involve that field need to be updated as well. So while indexes are great to optimize your read operations, they can impact your write workload. So it's not a good idea to have huge indexes. But covered queries are worth considering where your query is returning a large number of documents, but a small number of fields. We've seen covered queries, the performance of a covered query improve by like 99% or 99 times. The impact of creating an index can be huge on the operation response time and on the cluster resource usage. Here's an example of a covered query. Again, I apologize for the size of the text, but I just want to give an example. So here we're doing an aggregate operation. We're matching on a field A and we're sorting on a field B. So behind the scenes, I have an index on field A and B, which supports the ESR rule. We don't have a range match here. And we are projecting just the A field and the B field. And so in this case, the query, if we do an explain, which I am doing there, we see that the query involved a projection stage and it used an index. And we see it returned 9 documents. It examined 9 keys and no documents. So I love to see this. I love to see this as a result of some recommendation that I've made to a customer. And you can see the execution time in milliseconds was 0. So it's less than 0 milliseconds. So do consider covered queries if you need to optimize queries that return a small number of fields and a large number of documents. One of the pitfalls that we see a lot of, which causes cluster resources to be saturated and for large collections, are blocking sorts. So blocking sorts are sort operations, and blocking operations are operations that need to complete in their entirety before any results can be returned. So we have other examples like lookup, bucket, that's a blocking sort. But we often see sort operations which don't need to be operations at all, because if you can use an index to return the results in a sorted order, then there's no need to do a sort. The sort is already done when the index was created. So one quick win to optimize blocking sorts on large collections is to just make sure that you have an index to support that query. I have to be careful not to say cover that covers that query, because that means something different. So yeah, sort operations are extremely expensive on CPU, on disk, and the way to avoid them is to return the results from an index which is already sorted. The next pitfall is our regular expressions. So again, we often see queries that use regular expressions. We use regular expressions for text matching, and they don't use queries very efficiently or indexes very efficiently. If you think about it, if you're using a regular expression, you're matching a pattern. So you're not just matching the value in the index keys, but you're looking inside of it, and perhaps, you know, scanning character at a time. So if you can avoid using regular expressions at all, just don't use them. We have some alternatives and we have some ways to tweak them. The first thing is try and anchor the regular expression. So that you're just looking at the beginning of the index value. So that can often optimize the query. And if your regular expression is for a case insensitive match, then we recommend don't use regex, use a case insensitive index. And you can use the characters less than or greater than rather than regex. For on-prem, not Atlas, then you could consider a text index, but I have to warn you that they are extremely expensive on memory. But if you're an Atlas customer, then you should, if you've got an Atlas cluster, use Atlas text search. It's really good, and it's one of our products that we're investing a lot in. Very performant. So those are my recommendations. If your queries need to do text matching, try and avoid regular expressions, particularly case insensitive regular expressions. A few tips on optimizing your write operations. As I said earlier, indexes are great for read performance, but remember, for every index that exists on a collection, where a field exists in an index, then updating that field also causes the index to be updated. And sometimes you see that in a log file. When we're analyzing logs, we'll see like an update operation updated 10 documents, but it updated 120 keys. So that means there's at least 12 indexes with that field in it. So what we recommend is that you go through your indexes. When you're creating a new index, go and look at the existing indexes and remove any index that exists as a prefix to another index. Because remember, if we have an index on A and B, it supports queries that filter or sort on A and B, but it also supports queries that just filter on A. So any index that exists as a prefix to another index can be removed. There may be some indexes that are not used. We have a method called index stats that will tell you the last time that an index was used. And I should mention at this stage that for Atlas clusters, the performance advisor is actually really good now at recommending indexes and also at removing unused indexes or indexes that are prefixes. And it's improving all the time. So yeah, remove unused indexes. The other thing when you're looking at optimizing your write operations, array updates. So Rita talked about embedding relationships. And sometimes those relationships can be long lists. So that's okay to an extent. You know, we support large arrays, but in the interest, you have to think about the impact on your write workload if you are updating very large arrays. So if it's possible at all to just add to the end of the array, then the write operation will be smaller. So we recommend using push operators like push and pop to update the array if your use case supports it. And this is more performant than rewriting the full array every time you need to add an element to it. But you do need to watch for duplicates if you're just going to pop a value onto the end of an array. And we don't like large unbounded arrays. So again, when you're updating them, depending on the way you update them, your write operations can be huge. So updates outside of an array, we recommend using $set to avoid updating the entire document. So if using $set, you only update the fields that are specified with set. So there are just a few tips on optimizing write operations. And we also often see issues where the customer is doing some big bulk write operation and it executes very quickly. But don't forget that in MongoDB, you have a replica set where the writes occur on the primary node and they need to be replicated to the secondary nodes. And very fast writes on the primary need to be written to an op log, which is replicated to the secondaries. That involves a lot of read operations from the primary, and sometimes that saturates the resources. So what we recommend is to use write concern set to majority. So the write operations will be replicated to the majority of data-bearing nodes, and this also serves to add durability to those write operations. Rita already covered more than what I was going to say about schema design. So for linked relationships, if we need to access them, we need to use lookups. Lookups are blocking operations, and they tend to slow things down, particularly if the collections are large. So in the interest of performance, it's really important to get the schema design right. And you know, the data first, the query first approach is a good one to take. And unfortunately, we do see an awful lot of issues where the data model is like modeled as a SQL data model. And as you know, schema issues are not easy to fix. So you can't just tell a customer to go and fix the schema and you'll be fine tomorrow. Usually it takes a while because schema redesign involves a lot of regression testing and redevelopment of the application. So it's important to get that right at the beginning. So think about embedding relationships. Rita has given you some links to some really good blogs on the suitable patterns for modeling different types of relationships. Yeah, and as I said, avoid large unbounded arrays. And something else to keep in mind is that, and we see this very often, is that we have an issue, a customer opens a case, all of a sudden everything has slowed down, the customer has made no changes, they don't know why. And usually this happens because the data volume has grown and therefore the queries are accessing, scanning more documents, the indexes have grown larger. So it's important to manage your data volumes where your use case allows that. And we have options to do that. We have TTL indexes, time to live indexes, which can be used to expire documents once they reach a certain expiry date. Or for Atlas, we have online archive, which allows you to move the lesser access data into slower storage. So I think Rita covered this rule of thumb. We have a rule of thumb for data modeling. The data that's accessed together should be stored together. Finally, I'm just going to tell you a little bit about the new collection type, time series collections, which are suitable for certain use cases which involve ingesting large amounts of data that need to be accessed based on time. So we see a lot of suitable use cases from stock market or for gathering sensor information for machines. So with time series, we can expect that the data footprint, particularly the index size, should be smaller because data is stored in buckets, where the bucket size is determined by the granularity and the ingestion rate of the data. So basically, we're taking in a load of data, and all the data for a particular second, if the granularity is by second, are all stored together in one bucket. So the objective of time series is to make the data ingestion, data loading time faster, and also your retrieval faster. So results in a smaller index size and data footprint. You can group this data by meta field, for example, symbol or source device, to make it easier to access. The read performance gain for time series we have seen is very dependent on the data patterns and the cardinality of the meta keys. So again, you need to think about how you're accessing your data, query first. But it's certainly something to look at. I've just added a link there as well for more information on time series. So to summarize the recommendations, so to reduce, to optimize your workload, make sure that your read operations are indexed, particularly the read operations that access a lot of documents. Remove unused indexes. Model your schema to embed documents and minimize lookups. Avoid regular expressions where possible. Use Atlas Search instead. Manage your data volumes and leverage the Atlas Performance Advisor and the Profiler if your cluster is on Atlas. So the Performance Advisor will from time to time make index recommendations. It analyzes your workload and it'll make index recommendations. Now, it can't be guaranteed to make all of it to optimize your full workload, but it certainly goes a long way. And then it'll also recommends, it'll pick up on schema anti-patterns, such as large unbounded arrays, and it'll also make index removal recommendations. And then the query profiler will show you your long-running queries. It'll plot a number of dots on a graph, and where the vertical axis shows you the time that the query spent executing. And the dots are color-coded to represent different collections. So it's quite easy to click on a dot and find out, to see the explain plan and examine the work that that query had to do. And if you're not using Atlas, just use explain to look at the query execution. Yeah, and always test your indexes in a staging environment before you roll them out to production. And then finally, this isn't really about query tuning, but in a lot of cases, you can consider directing some of the read workload to secondary nodes. So the intention of replication is not so much for scalability, it's for failover purposes, but you do have more than one data bearing node typically, and a lot of time you can consider redirecting some of your read workload to secondary nodes. And keep in mind that if you do that, you do risk stale data, but that is typically only a couple of seconds unless you've got a lot of replication lag. So that's all I have to say. Thanks for your time. Does anybody have, take a question now? Okay, does anybody have have a question?
Yeah, so I've been using the Atlas product quite recently, and it's a great presentation. I just want to, is there actually a bad thing that if you don't understand what's going on behind the scenes because you use the Atlas product, which takes care of all the heavy loading for you, could you run into problems if you actually don't understand what's going on behind the scenes? Let's say, for instance, the query feature. So you want the text index, would that considered to be a problem if you don't know what you're doing?
Yeah, so text indexes specifically, they are a feature that have been around for a while, and they have been somewhat being replaced by Atlas Text Search. So if you want to understand more, we do capture a lot of information, and some of that we make available in Atlas through the UI. So the profiler is actually a good place to start if you want to understand what's going on. So the profiler will plot the long-running queries. And have you used the profiler?
No, because I'm not using the paid version, so I haven't got around to that just yet.
Okay, yes, you need, you need to be on at least an M10 or M20.
So, yeah.
To use the profiler, but it's super. So it'll show you straight away which queries are taking the longest time to run, and then you can just click on them and you'll see the explain plan. And so the explain plan will show you if the query involved a sort, which is a blocking sort. Remember, if it's using the index to sort, it doesn't actually have to sort. The index is already sorted. It will show you the number of documents examined, returned, and keys examined. It will show you the index that was used. Sometimes queries pick up the incorrect index. So I would say the profiler is a good place to start. As well as the profiler, then we have the raw log files. So you can go through the log files. They log operations that take longer than, I think by default it's 100 milliseconds, but that has changed recently. It goes lower than that if you have faster queries. So the log files show you a lot of information. And then if you want to examine the kind of guts of what's going on in the cluster, like the resources, CPU usage, there are metrics in Atlas which show you CPU usage, disk IOPS usage, swapping. There's a lot there actually. Query target ratio is also listed there at a granularity of, I think it's 1 minute. Then also we have a tool to analyze diagnostic data, which is like the metrics, but the granularity is much smaller. So you might have a query that lasts 10 milliseconds, but some of our customers see that as a high latency. So then we can get that information and analyze it. Does that answer your question?
I just wanted to add to this, like all these things explained are also accessible through MongoDB Compass, which is a GUI tool, which I find very useful. So yeah, I just wanted to point that out as well, like things like explain plans and index performance, and even just like the schema analysis, because like you mentioned, schema design is very important. So to see your patterns, your outliers, your data types, all those things are much more easily accessible through Compass. So
yeah, that's, I'm glad you raised that, because I think Compass deserves a separate talk, and I would recommend Hannah maybe to include it at some future talk. But Compass is a great UI which gives you so many features. So yeah, regardless of whether you're using Atlas or not, the latest version of Compass in particular is super to assist in building aggregation pipelines. And yes, you can see your documents, you can see the results of each stage in an aggregation pipeline and use explain. So thank you for raising that.
And even better, you actually could do copy of code examples.
Actually, yeah, I'm actually in love with the new version, because you could build your aggregation pipeline and then you say, well, I get it, but now I want it back in my code, and I want it. You actually can go there and say, "Oh, I'm working in Java," and it will transform your aggregation pipeline in Java code. It's really cool.
Yeah, I saw that recently. The latest version is super.
it's free. So
And it's free. Yes.
Hey everyone, so I'm an Android developer in Zendesk. My official title is software engineer, but that's just the official title. So I've been working on Android apps and SDK for the last 3 years. So just working, is it? Yeah. Okay, cool. It's fair enough. Sorry about that one. So basically, start again. So I'm a software engineer at Zendesk. I worked on Android applications and SDK for the last 4 or 5 years. I've worked mostly on enterprise applications. Yeah, I might as well because that's too short. Yeah, this is better. Yeah, so I've been working on Android applications. So more specifically, the EasyJet application. I've worked on the first Etihad application. So I've worked on quite a lot of enterprise applications over the last years. More specifically, recently, I'm working on the messaging SDK in Zendesk. So basically, I've been working on Android for like 6 months there in Zendesk. So today, I'm just going to introduce you to Kotlin Multiplatform with the RAM SDK. So this is quite recent Kotlin SDK that's been developed in the last year or so. Don't quote me on that. So basically, I've been doing this as a side hobby. So I've been integrating Kotlin Multiplatform with this library that helps me kind of build my app faster. Because at the end of the day, we all want to build apps faster to production. So anybody here actually use Kotlin Multiplatform, just or even heard of it? No? Okay, cool. At least one, that's good. More audience. So first of all, that's the first thing that I'm going to talk about. So what is Kotlin Multiplatform? So it is a platform that allows you to share code across platform between Android and iOS. So you probably heard of Flutter, React Native. They are more so on the single code base, like the UI, whereas as opposed to the Kotlin Multiplatform, that tries to go down the layer. So it's more focused on the business logic layer. So in this case, you want to keep the native feel of Android and iOS because Android have its own specific design guidelines and iOS has also. So this is the kind of what they're trying to solve here. So just to give you a bit of history of RAM. So RAM has been acquired by MongoDB in 2019. So for $39 million, don't quote me on that again, please. I'm probably wrong in that figure. So RAM established itself at the mobile database platform. So if you've been in Android development, you've also probably used a RAM standalone Android application, and you probably use RAM. So with MongoDB, it now offers the capabilities with the Atlas platform. So that allows you to kind of hook into, let's say, offline synchronization. Just for this talk, I won't be diving into that specific area. I'm just going to show you the bare bones of the RAM SDK, just how to get it up and running very quickly. So how can the RAM SDK help you, like just help me? It can share business logic. So the whole idea behind this is you want to share your database business logic across both platforms. Why? Well, because you want to get your code to production as fast as possible, and this reduces the cost. So if you have your single source of truth for your database, what this does is that, okay, I'm basically saving myself time. I can focus on the UI and hook it up to UI where I have the code in one place, one single source of truth. So that basically reduces the development cost by probably maybe 20, 50%. It's also an object-oriented model. So just like in the previous talks, you can access the object directly to the RAM instance. So basically, you're focusing on writing the code first, as opposed to the other way around. As an intuitive API, so the API itself in the RAM SDK is actually very easy to use. So it actually leverages the Kotlin DSLs and also use the NS predicate, which is very familiar for anybody that does iOS development. This uses the style for the query optimizations. I will show you that in later on. I'm going to do a live demo and I'll show you exactly how that actually works. But of course, it's actually open source. So you can go to basically this URL here, itself, RAM Kotlin. So you can actually contribute to the Azure SDK itself, or you can raise issues as well, which is actually highly encouraged. Well, just before I start anything, it's actually still in beta. So please take careful consideration if you want to push this to production. So don't say I didn't warn you. So if you use Kotlin Multiplatform, you probably use the new memory model. So Kotlin Multiplatform has basically had a lot of issues around concurrency. So you probably want to use a new memory model, and that is actually possible. but there's a few things you have to kind of tweak. So there's a catch to this. So the library is actually itself is still implemented against the old memory model. So you have to do a few workarounds to actually get it working with the new memory model. To do that, you can follow these specific instructions. So if you go to that link, it will show you exactly what you need to do. By default, it actually, if you use coroutines, which is basically a concurrency library framework offered by Kotlin, you have to use the library itself actually supports the non-native coroutines artifact. However, if you want to override that nonsense, you can just go to your grader.properties file and just basically enable the new memory model with experimental. So the keyword experimental, please do not push that to production just yet. So yeah, so you have a binary.reason. So this is kind of what the new memory model is supposed to achieve. But the problem with the RAM is, okay, it doesn't actually support that out of the box. So you're going to have to disable that for now. And then, like I said, there's more information on the object reason. That's an entirely different topic itself. It's quite a complicated one. So I recommend read this one and in your own time. So let's get to the actual writing the actual code. So the first thing you want to do is you want to code first, right? You want to actually just get your object up and running. To actually do this in Kotlin, it's very, very straightforward. You need to define your object that you're going to interact with the RAM instance. In this case, let's say, for example, you've got to be a database model. And in this case, you may have a standard RAM object. This is actually provided to you by the library itself. And here you may have some additional properties. So you have some data types here. You have an ID, you have a name, image URL, or some ABV, which is if you're not into craft beer or anything like that, you probably see that's essentials of the author, just in case you're wondering. So once you have a model ready to go, you can set up your configuration. So what you're going to do here is you're going to basically create this RAM configuration builder object. And within that, you define your schema. So your schema is basically this property here. You basically have a set of. The set of means that you can have one or many objects. Just be aware of that. So in this case, we're just going to pass in one, and then we build it. And then we basically just open our connection to our RAM instance. That's pretty much all you have to do to get started. And that's basically maybe 4 lines of code. So that's pretty great. So what we're going to do now is actually I'm going to open up a project and show you how you can actually build this from start to finish. So here we're just going to build a very, very simple application with a list of beers that we can add and remove. So if you're into beers, great. If not, don't worry. The source code is actually going to be on GitHub. So if you want to look after this tutorial, please feel free to look at the code. So I am going to jump into the code. Just want to make sure you can see that. Yeah, if you can't see that, if you want to make it bigger, just let me know. I'm probably going to have to be hand-free because I literally can't type with one hand. Let me try it out. Okay, cool. Yeah, so basically what I'm going to do here now is I'm going to go to the first thing that you'll probably interact with, so the structure. So here we have your basic Kotlin multi-platform structure. So what you will probably see here is the Android application. So this is where your Android application, this is where your native Android application actually lives. And then here you will put your iOS code in the iOS app directory. So this is where all your native code actually goes. So this is where the kind of the puzzle starts. So you start with your shared module, and this is where everything glues together for the Kotlin multi-platform. So first of all, we're going to have a look at our Gradle file. So the first thing you'll probably notice is in the top of the file there you have the multi-platform. So that is basically very, very important that you actually declare that. Otherwise, it's not a multi-platform project. Basically, then it's actually a library. So just be aware that this is not actually an application. So therefore, this is actually a library. So it may be very, very important to actually consider this as a library, not an app. The same for iOS as well. The equivalent for that would be a framework. So you're basically going to import that into your iOS and Android app. You can also use CocoaPods or SwiftUI, entirely up to you. So that's really good. So you have that flexibility. But here I just have some configuration here. Here, this is just literally the building blocks to get you started. Here, you just define your Android, iOS. These are basically just for the simulators on iOS. And here you can have your CocoaPod integration as well. And here, this is where you particularly declare your dependencies. So let's say, for instance, let's go into the package structure here. So we've got three kind of packages going on here. We've got Android main, common main, iOS main. Most of the time, you'll be spending most of the time in the common main directory. Reason for that is that's where all your shared logic is going to be shared across Android and iOS. The only case where you probably use the Android main or the iOS main folders is, let's say, for example, in your share code, you want to maybe use the expect or actual operators. They're basically saying, okay, I want to deploy this code just to iOS or just to Android. That's for very rare cases. But if you have that use case, that's there for you. But for that purpose of this demo, I won't be doing that. So here we're going to jump straight into the common main folder. So what I have here is a few things going on. So as first, I'm declaring my RAM object, which basically is going to open my RAM instance. So here I'm just going to declare very simple properties here, like we just seen before in the slides. And then here, I'm basically going to create my database class. And within this database class, I'm going to have my setup here, just as we've seen in the slides. So here I pass in my schema, and I'm basically going to open up my connection. So as you can see here in the example that we're going to do, we're going to build a save a beer, and then we're going to find all beers, and then we're going to remove a single beer, and then we're going to remove all beers. So this is a very simple CRUD application. So right now, I'm just going to write the save beer. So here we got a couple of things going on. That should be within this function. Cool. So here we got the kind of model. So what we're doing is we're basically adding the data to the model. So we're feeding that data. And we're passing in this kind of class here, beer data. The reason I did this is because I wanted to have a separation of concerns here. So I don't want to expose my realm logic to iOS or Android. So for this case, I just kind of encapsulated that logic and passed it in as a parameter. It's good practice because let's say, for instance, if you change your model down the line, you don't want to break the existing code. So it's good to keep that in mind. So once we've done that, we just kind of pass in a couple of parameters, off we go. And then the most important ingredient here is that we call the RAM instance here, and we do a write blocking. So write blocking means it's going to start the transaction, and it's going to do a blocking operation. So that means we want to spend the current thread while we actually do this operation. And then here we basically call this, and then we copy that to the RAM instance with our object that we just created. That's very simple, straightforward. I can see it's quite clear that you're actually just adding things to the database. And now, what if we want to actually just find all of these beers, right? So there's a little bit more code that we have to write, but it's still quite straightforward. Find our beers. Yeah, so there's quite a lot going on here. So the first thing we're actually doing here is actually we're creating the actual RAM instance database. So we kind of want to query for this model that we defined in our schema. So what we're going to do is we're going to use something from coroutines called flow. Reason for that is basically we want some back pressure. So we don't want to block the main thread. We want to make the async operations. So we call as flown, which is basically just a extension function. And then what I'm going to do is I'm going to map this to a couple of things here. These are kind of callbacks that are given back by the RAM SDK itself. So if I just jump into these guys, you actually have the definition itself. So basically this initial results callback is basically saying the first time I load the app, this is going to be the initial state, the initial result. And then it's also going to have another callback called updated result. So let's say, for instance, I add a beer, it's going to call this updated event instead. So it won't call the initial one, it'll call the update, and it will update the actual flow. So basically, I'll just create a little kind of function here to kind of transform this beer data object into a kind of encapsulated data class, because I don't want to expose that to the Android or iOS applications. So once I have that already, I have that glued up. So the last two things I want to do is I want to have the ability to remove by ID or just remove everything. So first thing first, I'll probably rewrite the remove function first. So here within this function, we're just basically going to say a right blocking operation again. And then within that, we're going to have a query. So basically what we're going to do here is we want the query to get to specific ID. So I want to find the ID in that I've defined in that model. Once I've found it, I'll just call this method called delete, which is provided by the library, and that will remove it for you. So if you want to know what's going on in the hood, you can just step in and actually read the code yourself. So if you're into that kind of thing. So once we've removed the ID, now we can go ahead and write the function if we want to basically remove all of it once. That is relatively straightforward. So within this function here, we're just going to basically slight different, the same principle that we had here before. But the only difference here is we're going to use this find function. So this find function is basically going to query all the objects in the database for me and return them back to me. And then once I have all that results, I can call the same exact method and just delete it. That's pretty straightforward. So that's pretty much everything that's done all in one place. So now we can actually glue this to the Android application and the iOS application. So if you're looking at Android app right now, we can see that you have a package structure in here. So I kind of already glued up some of the code just to kind of save me a bit of time here. So I'm just going to show you how you actually call these functions directly. So first thing first, we need to import this as a library. So just as remember, as I just said, this is actually treated like a library. So all you have to do is just import it like any regular library that you would use. So here, this is basically importing the shared model. So once that's all done, we can now call those functions that we just created. So I'm just going to go into the view model. So I kind of done this code already prepared for me. So all I have to do here is write a couple of functions. So what I've done here is I injected the Bears database into my constructor so I can use it. I'm actually using the help. Don't worry if you don't understand any of the stuff that's going on, you kind of get the general idea. So within this function, I'm basically going to call the database to fetch me all of those Bears that we created. No, not that one. Yeah, so I'm basically in Android development, we have to make sure that we're not actually blocking the UI. So what I'm doing here is I'm basically changing my thread to the iOS thread, simply because I don't want to block the UI when I'm actually doing a database operation. So make sure that you're doing it on the iOS thread. Very simple. And then what I do is here, I'll just call my find RBS operation. And here I want to make sure that I filter out any duplicates. So I don't want to have one of the same type. So I just filter that out. And what I do is I collect the flow, and that will return me either the state. So what I'm going to do here is just simply update the state if it's empty. I'll just show an empty state. Otherwise, I'll just update the value of my results from that stream. And that's pretty straightforward. That's actually ready to go. So here, I'll actually just write my save function as well. So here, I'll just have to call Bears database. Here, I'll just basically call the same function. And here, I pass in the data that we're actually mapping to the actual Kotlin code itself. And then here, we do the same thing. And here, I'll just pass in the ID. And then the same for this one as well. So that's pretty much all wired up, ready to go. So without covering any more detail, I can show you exactly the UI itself just a little bit. So here I'm just basically have a composable. So if you're not into Android or iOS development, there's a new framework out there called Declarative UI, which is Compose and Swift UI. So this is a declarative approach. So simply I'm just setting up my view model, I'm wiring it up and ready to go. So once I've done that, I want to fetch the Bears. So as you remember, I want to call that function directly. And then once I have it, I check the UI state and I update the UI accordingly. So you can see here, I pass in a couple of things. Basically, when you hit the button, you call that function itself. So I'm not going to go into too much detail, but you kind of get the entire picture. So this is the app itself. But first, I want to show you the iOS code. because that would be evil adjusted if I didn't. So here, basically, you have the same principle. We have the view model, a view model in the Swift code as well. This is Swift. So here, I just basically set up my BS database instance. So I have to create my instance. And then once I've done that, I just kind of create in some states, same as iOS approach, where you have to set state, empty state, or error state. And once I've done that, I have a function. I just want to load all the BS. So within this function, I'm doing an asynchronous operation. So I'm trying to collect from a stream. So as you can see here in line 27, I basically called this function called find RBS native. You'll probably be wondering why is that called native in this code. Just as a known caveat, I'm actually using a third-party library that handles the whole concurrency for Swift, because the problem is in Kotlin, there's no, how to say this, support, because in Swift, there's no such thing as a suspend function and so forth. So there's like the compatibility between the two platforms. So this library actually handles that stuff under the hood. So it basically saves me writing all that lines of code in order to achieve what I want. So if I just show you that, actually this library, where's it? Yeah, this guy here. So I will share this link with you after the presentation. So once I've done that, the same principle that I've done in Android, I check if the BS are empty. I update the state to empty. Otherwise, I pass in a successful state with the BS. So basically, I want to run this guy. So here we got on the left, we got iOS, and here on the right-hand side, we got the Android application. So first, I'm going to run the Android application and pray. This is what happens when you do live demos, things just explode. So. Okay, I think it did. Okay, cool. So as you run the Android application, so we have that up and running. I've already made sure I run the iOS app as well. As a quick tip, you can also run the iOS application through the Android Studio IDE as well if you have this Azure Kotlin Multiplatform plugin. So that's actually quite handy if you're actually doing like switching back and forth. Building now. Taking his time. Yes, there we go. Cool. Great. So right now we can start adding some beers. I'm actually quite thirsty right now. So let's go ahead and add a few. So here I might add a beer called 5 Lamps Ale. And I just add the brewery name. And here I add the percentage of alcohol. Like again, this is just me random data. This is not the actual percentage. And then I might want to add another one. So let's say, I don't know, Happy House, Happy Days, I think the name of it is, from Rascals. I don't know if any of you know what your craft is, but no, there, okay. This is just me showing off. And then let's say, I don't know, 5 Lamps Ale Lager maybe. Just add one again, and I go back. As you can see here, I have my list of basically items. Let's do the same on Android, just to actually prove that it actually works. So here I can go ahead and add. You can see here it's added, and I'll add another one. Let's just put 4. Another one, and I'll just call it Happy Days. Cool. As you can see here, we both have logic shared, and they're both on the same platform. So what we just done there was that we have all the business logic in one module, and they're both using the same logic. So all I had to do was just hook up the UI, and we're basically good to go. So let's do a few more things here. Let's say, for example, I just want to remove one item. Let's actually demonstrate that. So on Android, let's just go ahead and swipe delete. That's gone. Same here on iOS. I actually didn't do swipe delete on SwiftUI because I'm very novice at that. So I just did a simple button to demonstrate. So here it's now removed. And let's say I just want to clear all of them because maybe I don't like them anymore. But that's gone. Gone. So as you can see right now, what we've just seen there was that we've written all the UI logic respective to each platform, but all the business logic is shared between the two platforms. And that's pretty much it for my demonstration. And if you've got any question that you'd like to ask me right now, please go ahead.
I just have a general question, not related to the presentation, but I wanted to know how you came across Realm. Is it because you were using Atlas and then you got introduced to it, or how is it that you started that?
Yeah, I heard the question. It's okay. Yeah, so how I come across Realm, because I was doing a side project in Kotlin Multiplatform. So basically, I was looking for a solution where I can basically hook up a database relatively quickly. And I came across Realm because I think I came across in a Twitter post, I think by John O'Reilly, who's also another developer who works on Kotlin Multiplatform. So he saw this new library that was out there that was in beta. I didn't mind because I wasn't going to production at that time. So it's good to kind of find the library where it makes things simple. And it basically, I don't like SQL because from my experience using SQL, I have to kind of set up the schema first and then do all that design stuff. I just want to code first, off we go, and done. So that's my reason for using it.
So how was your experience starting? This is the first time you're using Realm. How was your experience as a beginner? Was it like easier, relatively quicker?
In terms of Realm, I've actually used Realm before, but more so in the Android context, only context. But for the Realm SDK and Kotlin, it's actually fairly straightforward because it actually follows good API best practices. So it's actually relatively easy to understand the actual documentation that was provided. So the documentation is pretty easy to follow for anybody that's a beginner or intermediate. So it doesn't matter what level you are. If you follow the documentation, you get a good understanding.
Thank you.